Hello everyone, welcome to the video lecture series on Advanced Separation Process. Myself Jaimin Pandya, Assistant Professor in Chemical Engineering Department of LJIET Institute of Engineering and Technology. So let's continue with the chapter number 2, which is the membrane separation process. In this lecture, we are going to discuss about the porous membrane, non-porous membrane and various methods for characterization of membrane. So, before describing the membrane characterization method available in purpose for which they can be employed, it is actually important to understand pore size, what pore size we are going to cover. So, we have been discussed about the pore size in our various lecture. So, you may understand that the pore size actually decrease, the membrane characterization also become little difficult. So, membrane can be classified based on two categories actually with respect to a characterization. So you can see one is a porous membrane and second one is a non-porous membrane. So the porous membrane in which the pores are present and they are basically microfiltration, ultrafiltration, all these membrane, and non-porous membrane are the dense membrane are usually used for the reverse osmosis as well as gas separation application. Now in microfiltration and ultrafiltration membrane, fixed pores are present which can characterize by various techniques. So the pores are actually fixed with the already present. So we need to characterize them that distinct visible under the different technique. In order to avoid confusion in defining porous membrane, the term porous has been used throughout this course for the both microfiltration and ultrafiltration instead of frequently using the definition of microporous. So you can see definition of porous is more agreement with a definition adopted by the IUPAC. So this is the IUPAC classification of macroporous membrane, microporous membrane and mesoporous membrane. For the microporous greater than 50 nanometer, for the mesoporous between the 2 nanometer to 50 nanometer, and for the microporous lesser than 2 nanometer. However, we are discussing only pore diameter. So whenever we are characterizing the pore diameter. So this implies that microfiltration membrane are porous medium containing macroporous and ultrafiltration membrane containing mesopores in top layer. So hence the definition porous cover both macropores and mesopores. So with the membrane of this type, it is not membrane material we are going to characterize, but pores in the membrane we are going to characterize. So when talking about the porous membrane characterization, please note that we are characterizing the pores. The membrane material is nothing to do with it. The pore size and the pore size distribution mainly determine which particle or molecule are rejected and which will pass through the membrane. So let us now again discuss little about the porous and non-porous membrane and how they are actually work, their mechanism actually work. So you can see first the non-porous membrane, which is actually also called dense membrane. So they do not have any pores or distinct pores. So the working mechanism actually is a solution diffusion. Solution diffusion is essentially two factors which play a big role, such as one is a solubility and second which is a diffusivity of solute that we are going to transport across the membrane. So initially solute which are supposed to permeate through the membrane will come and sit on the surface of the membrane and solubilize. They will be solubilized inside the membrane matrix. So once they are solubilized, they further diffuse across the membrane to the permeate side. So here there are no pores in non-porous or can say that dense membrane. Only solubility and diffusivity is playing important role for the transport of the solute or solvent from the membrane. But now let us look into the porous membrane. So porous membrane, two distinct features can be transport mechanism can be identified. One is a molecular sieving, and so molecular sieving is a something in which basically size exclusion. So based on the size penetration is a happening. You can see the cylindrical pores which are being shown here, and particle which are larger than the pore size are getting retained on the surface of the membrane, where which are smaller than the pore size are permeating through the membrane. So this is a extremely high separation can be achieved. This is called molecular sieving and neutron diffusion. Neutron diffusion actually take place in for the gas separation process. The separation also achieved very high level of separation can be achieved in gas separation by the neutron diffusion. In neutron diffusion, particles which are smaller than pore diameter will eventually collide inside the pores. So molecule travel it get collide many times inside the pores and travel across the minimum path length and then come out the permeate side. So this is actually known as a neutron diffusion. So one important but often not clearly defined variable in characterization of pore membrane or porous membrane is shape of pore or geometry. Do not mistake that all pores are cylindrical or parallel in nature. It never so. Expect few zeolite and available either synthetic zeolite or natural zeolite have a cylindrical pore. So when you talk about the characterization of porous membrane, it is actually two types. One is a structure related parameter and other is a permeation related parameter. So that is see under the structure related parameter. So we are basically determine pore size distribution of top layer thickness and surface porosity, and in case of permeation relate the parameter. So we actually determine the separation parameter using some real solute and are more or less retained by the membrane surface. So this is called cutoff measurement or cutoff experiment. So it is often very difficult to relate the structure related parameter directly to the permeation related parameter because the pore size and shape are changed according to the membrane. So there are various techniques to characterize the membrane. But before going to characterize this membrane, let again understand what is meaning of the porous membrane and non-porous membrane. So in non-porous membrane, there is no pores. Transport of the molecule is done by the solution and diffusion. First, the molecule are set on the surface of membrane and transferred through the matrix to the permeate side. Where in porous membrane, there is a distinct pores where the solute or can say that smaller molecule than this pore size is passed through the membrane and bigger molecule that cannot pass from this membrane. So non-porous membrane have a higher permeation comparatively non-porous membrane. Non-porous membrane used in a reverse osmosis or nanofiltration, where porous membrane are going to use in a ultrafiltration and microfiltration. Now let us discuss various characterization technique for the membrane. For the performance test, membrane filtration setup are used such as a permeability, rejection ability, pore size distribution that can be characterized using membrane filtration setup or membrane assembly setup. To characterize membrane porometry, bubble point, mercury intrusion, gas adsorption and parometry are used. Using this technique, we can get information of membrane pores structure. Various microscopic methods are also used such as SCM, TEM and AFM. SCM which means scanning electron microscopy, where TEM which means transmission electron microscopy, and for AFM which means atomic force microscopy. Using this microscopy, we can characterize the surface cross-section feature, cross-section of the membrane or foulant or roughness of the membrane and surface morphology. Spectroscopic methods are also used for the characterization of method. Various spectroscopic methods such as FTIR, XPS, EDX and EIS. So using this technique, we can characterize the membrane and foulant functional group, element and chemical bonding, element mapping of the foulant, structure information on sublayer that can be obtained by the FTIR, XPS, EDX and EIS. FTIR which means Fourier transform infrared spectrography, where XPS which means X-ray photoelectron spectrography, where EDX which means energy dispersion X-ray and EIS which means electrochemical impedance spectrography. Then when other methods are also used to find out the hydrophobicity, surface charge and interaction force using the goniometer, streaming potential and AFM force measurement. So this all technique we are going to study in this chapter. This figure shows schematic and photograph of modern TEM and mechanism of imaging system of TEM. So let us understand how the TEM works. So you can see the figure on your screen. So this is a structure of TEM, or can say that transmission electron microscope. It is a optical part. You can see there is a something written high vacuum, because the TEM itself, the entire setup work on high vacuum. So we will study why we are going to take high vacuum in TEM setup. So there is a light source, there is a condenser, there is a special stage, there are objective lens and projector lens, then there is a screen and photographic film and CCD camera. So you can see entire setup in this image. So you can see here electron gun which provide the electron. This one used for the accelerate the electron and transmit to the condenser lens, and then transmit to the second condenser lens. Then we have specimen. So this is a specimen, your membrane material or anything or any polymer, and then it go pass through the objective lens, and then there are intermediate lens, then there are projector lens which finally projecting the image to the screen, and intermediate lens and projector lens actually helping in magnifying the rays or image whatever is getting produced due to the scattered electron through the specimen. In TEM, the visibility light ray is replaced by the electron ray, and glass lens for visible light are replaced by the electron magnifying lens. The TEM contain further feature arising from using electron and illumination. For example, vacuum environment is required. As I was telling, the vacuum environment is required for TEM, which is not so for the SCM or AFM. So because collision between high energy electron and molecules significantly absorb the electron energy. So if there is no vacuum, when the electron very excited state, they will collide with each other and along with air molecule, and they will try to absorb energy. So that is not good. So that lot of energy will be lost and eventually you will not get particular image. So this is all about today's lecture. So in this lecture we discuss about the porous membrane, non-porous membrane, various characteristic method for the characterization of membrane, and talk about in detail in TEM, or can say that transition electron spectrography. So I am completing my lecture here. Thank you.